Good morning, guys. I believe we should have Sage joining us shortly, although he did mention that he has to have someone come out and fix something at his house, so he may have to run. Alright, well, let's just get started in case Sage had to go. Let's see. Alright, there are some new PRs this week. There's a couple of different Blue Store ones. This unified throttling model, it's a couple of different commits, but I think in general, one of the things it does is try to increase the queue depth for deferred writes. And actually, in some tests that we did just quickly last night, it looks like in at least the hard disk case, it is helping for small synchronous writes and random writes. So Nick, especially for some of the things that you were looking at, this may help on hard disk at least. It does not appear to be helping at all on NVMe. So that is something I think Sage is planning on trying to look at it more today. He actually mentioned that he thinks that there may be an issue with our flushing behavior that could be contributing to that. Oh, hey Sage, you're here.
Hey. Yep.
Do you want to go over some of the PRs here? I was just going to go through them, but you might be better at it.
Sure. Yeah. So this the unified throttling model one. There are actually two sets of changes in there. One are just targeted at improving things for QDIP1 on hard disk, which seem to be helping. And then there are two patches that simplify the throttling. But I think it's not quite right. So I want to run it locally with NVMe journal hard disk data and make sure that it's doing what it should be doing. Excuse me. But mostly that's fine. There's a pull request that tries to make Blue Store unshare blobs that get cloned, and then the only clone gets deleted, which should help for EC overwrite workloads. That needs testing and review and stuff. It's not super elegant or anything, but it needs to be just good enough basically to make the EC overwrite workload, not make every blob read only, basically. So, and then the point of that throttling thing was that Eric has a new throttler that is basically self-tuning. So the idea is that you would have one knob that you would set, and we'd have defaults based on whether it's a hard disk or SSD, where you'd basically say, I want this is sort of my target latency, and it would dynamically adjust the throttle to so that the batches that it's committing are sized so that we achieve roughly that latency, so that you don't have to sort of manually adjust those things. And so we need to, that'll only work if there's only one knob that has to turn. So we need to, but once that's in place, then hopefully we can then just set, hard disks are targeting, 100 milliseconds when they're fully loaded, and which means that you're basically doing 10 times a second you'll be going to the journal. You just basically choose how much overhead basically you have for that versus throughput type workload. And that hopefully will let us manage those QDEPs sort of automatically so that all the mClock and QoS stuff scheduling will actually work. Which it's looking reasonably promising, but we haven't actually run the throttling stuff through any performance tests yet to see if what impact it has on the overall throughput. So we'll have to see how that goes.
Sage, how difficult would it be to add something, just like a simple test in the OSD that looks at the disk and tries to figure out kind of what that target should be for you?
You could do that, but I don't know that that'll really tell you a lot, because you could figure out what the latency is for like a QDEP1, but that's not really what you're after. Like the fact that the hard disk can do an 8 millisecond write isn't the important piece of information. What you really want to know is the fact that there's, on a hard disk, for example, the fact that there's this overhead of journaling things and actually committing them, that is going to cost you 8 milliseconds every time you do it. The question is, do you want to do that on every single I/O so that you minimize the latency on each I/O when you have a shallow queue, or do you want to do it, once per second, so you batch up as much stuff as possible and you're maximizing the throughput of the disk, or is it somewhere in between?
Yeah,
probably it's going to be somewhere in between, where you're saying, I'm willing to spend 20% of my sort of disk time slice on doing sort of timely commits in order to get a balance between throughput and latency.
It seems to me like you could almost write a test, though, that would go through and do exactly that, and then kind of look at the spectrum and say, here's kind of where latency is, and here's where throughput is, and kind of
sort of pick the knee in the two curves.
Yeah,
I guess. Yeah, maybe. Yeah, it's going to be. We can't get too clever, I think, trying to understand the device, because it's a black box and it has complicated, weird behavior.
Yeah, true.
and there's going to be like, compaction that's going on in the background, and there's all this stuff going on. So I don't think we can get too sophisticated, because it's sort of doomed to fail. So I think the trick is trying to find as coarse a model that's good enough, I guess.
Sure.
So
I don't know if this relates to it or not. I've been doing a bit of testing with the 4.10 kernel, which has now got write-back throttling, and with the sort of file store that stops a lot of the read starvation during heavy writes.
That's good.
So I don't know if that would help in this case as well.
Well, it's not going to help with BlueStore, because we won't take advantage of that. It's probably helpful in that we want to do something similar, but I think we already are. We have a pretty limited amount of write back that we do in BlueStore. It's like 32 IOs at most, or whatever. It's like pretty small. Probably what that means is that file store is going to do a lot better, because it's not going to have this like huge amount of deferred work that gets piled up, and then you get this weird bursty behavior. It'll probably be less bursty.
Yeah, that's sort of what I've been saying.
A little bit. Yeah. Yep. So anyway, there's that. let's see what else. Some bunch of stuff merged, some BlueFS optimizations, very small. Let's see, the OSD remap stuff merged, I think actually a week before last, which means that we can get once you sort of get everything up to Luminous, you'll be able to get a perfect distribution of PGs across OSDs. So get rid of all that utilization variance, which will help a lot. There's some CRC stuff for PowerPC that's getting close. I think Kipu was fixing the build on that. Oh, I guess he merged it. Or he has a cleanup, I can't remember. Anyway, the ARM range things merged, but it's turned off by default. We probably need to do some testing and then make sure that I know RocksDB upstream was doing some work to make range key removals more efficient. I might want to wait for that. There are a couple of pull requests from Radoslav fixing stuff in the bitmap allocator. The first one is merged. It just reduces the amount of memory that it uses and makes I think there are fewer pointer dereferences. So that's good. There's another one that changes the allocator hint behavior. That one has not merged. That needs to be sort of cleaned up and gotten in a state that actually makes sense as sort of a proof of concept. And then there's another huge branch by Radoslav that's down here, I guess, the optimized processing of extent map and code sum. That one needs review and probably would break it up into smaller pieces. But I think Radoslav is fixing some things in Rados Gateway first. He's trying to get his authentication refactor merged there first, then come back to it.
Hello, Zaid.
Oh, hi. You're here. How's it going?
Yeah, I'm here. The AUF rework has been merged recently. Also, some features for Swift's feature parity, like bulk upload and similar stuff. But finally got some chance to get back to BlueStore. Sent two small pull requests today. One is definitely DNM because it's the one removing blob ref and switching to plain pointers.
Okay.
It needs a lot of testing. However, the first one is pretty small. It gives, in my testing, not official yet, I would say. Only on my laptop, not on server. It gives me around 5% of more IOPS in the case of handling small radius objects. However, it's pretty straightforward. Yep. Yeah, okay. It looks that compiler, pretty straightforward stuff. I cannot imagine what it could break.
Cool. I will take a look at that one. Awesome.
I will definitely make some performance tests and try to input them into the ticket, into the pull request.
Sounds great. Okay. Okay, and I think the last one, that's not the last one, but the next one that's sort of in line on BlueStore is the KV sync thread. This was originally a patch from Intel. Igor cleaned it up. I rebased it again. But then Mark saw some hangs, so I needed to make sure that's not actually hanging. But that just makes it so that the second half of the commit thread that does all the completions is in a second thread. So there are actually two commit threads, one that does all the submission and one that does the completions. So I want to verify that A is stable and B that it actually helps. Well, it seems pretty clear that's going to help, I guess. So, and then once that's in, then I can finally go back to the BlueStore RTC branch, which is basically trying to do synchronous commits in the queuing path when possible, and get that rebased and cleaned up and stabilized. That'll be good for like Optane journals, basically, where you have super fast write bandwidth, low latency. I think that's it for BlueStore. Let's see what else is here. There's a bunch of RDMA work that's going on. RDMA, by the way, in async messenger is enabled in the default builds, and it seems to be pretty stable, as from what I hear. How my X guy, they have a production cluster with a test customer that's using it successfully, and there's sort of a steady stream of patches from the Marantis folks, not Marantis, Mellanox. So there's a possibility that that'll actually be non-experimental in the Luminous release. We'll see. If you're interested, let us know. And let's see what else. There's a couple other ones here. I haven't looked at this one yet. There's a combined callback of op commit and op applied into one. I haven't looked at that one yet, but that's probably promising, at least in the BlueStore case. See, there's CRC calculations for zero buffers. I haven't looked at that yet. Yeah, there are a bunch of here that I need to go look at. And then there's this bottom batch that hasn't been looked at carefully, but needs review and testing, I think, mostly. I guess the big one probably to point out is Zipkin is this tracing framework that we've been looking at for like freaking 2 years now. There's a Google Summer of Code student who rebased and cleaned it up over the summer, but it didn't merge over the summer, sadly, and so it needs to be rebased again. I have at least the Rados portions of that rebased and building and ready to go. It needs to go through QA. And then once that's in, then Jason is going to take the RBD stuff and rebase that, because RBD has been refactored like twice since then. But that'll be encouraging. One thing I noticed about Zipkin was that the CNCF Cloud Native Computing Foundation has a bunch of like sponsored projects, and one of their sponsored projects is Open Tracing, which is based on, is it Open Tracing? One of these things, which is actually based on Zipkin. So that's kind of cool. Let's see. What else? I should mention the perf counters are getting some attention. There's a pull request that adds priorities to them to sort of mark how important and useful they are. Annotate them in the daemon so that then the daemon perf command can just show you the most important ones by default. It's doing a half decent job of that right now for OSDs. So if you do, instead of doing Ceph daemon and then daemon ID and then a command, you can do Ceph daemon perf and the daemon ID, and it'll do every second it'll spit out a line that shows you the interesting metrics, which makes it easy way to watch a daemon and see how many IOPS it's doing and how much BlueFS is writing to its wall and database devices and so on. So if you haven't seen that yet, you should check it out. Makes the perf counters much easier to consume if you don't have a whole graphing visualization thing set up for your cluster. And I think that's mostly it for the pull requests. Any questions or comments there?
Can you hear me?
Yes.
So there's a pull request 9431 that has been kind of languishing there.
Yes.
And I was wondering, like, if we could come up with a way to make some progress with that. My problem is, I don't feel like the people that did this, the perfect scale people, probably aren't the right people to be doing the actual commits, because we don't know Ceph well enough. But we know he found the performance problem and analyzed it, I think, pretty well. And
okay.
It was a shame not to take advantage of that. And what
Definitely.
do you think?
This sounds like something that might be up Radoslav's alley, if you have time or interest. This is basically, I think, so Joe Mario did this, is that right?
That's
and he
correct.
Found he was using perf to identify cases where there's cache line contention due to false sharing.
Yeah, it's a tool called C2C, letter C, number 2, letter C. It's not
okay.
upstream, but it's almost upstream. But but it's a tool that can show you cache line conflicts. And with that, he analyzed Ceph and the OSD, and basically found these two problems. One was use of IOStream, the IOStream C++ class, which apparently is cache line unfriendly, and that was a huge hit. and not hard. It's a very small amount of code that I think is affected, but it's
Yeah.
so that would be like the first thing to look at, and then if that gets cleared up, then there's this the thing you asked about, which was the cache line alignment of the data structures.
Yeah.
And go ahead.
I was going to say, it looks like the original PR was against Hammer. Is there any chance that you guys might be able to take a look and see how hard it would be just to resubmit one against Master?
Well, I think probably the changes should cherry pick cleanly because this code never changes.
Yeah.
I think the main thing is that we want to just separate it into different patches. So one of them changes the alignment for the logging class with all the mutexes. That's a pretty simple change. It just makes them all 64 byte aligned. Is that? I thought the cache lines were 128 bytes and not 64. Did I make that up?
With whatever, I thought it was 64, but my memory's kind of bad. It's too long ago, but I think.
Yeah.
But you feel free to ask Joe, and he can explain all the stuff that he did and how to use C2C if anybody wants to use it. And he did do upstream, Mark. He didn't use Hammer. He actually built.
Yeah.
He built. I don't know. It's a while ago. It's like 6 months ago upstream, but it was still.
Yeah. Okay. Well, anyway, yeah. So he's right at 64 bytes. This would be really easy to fix. Well, to just commit basically. Just put these in separate commits, and then it's just mostly aligning mutexes, giving them their own cache line when they're contended, which is pretty reasonable. So.
Okay, good.
I think somebody just needs to take a look. I guess the question is who has time to do that? Is this something that you're interested in looking at, Radislav? Or somebody else?
Peter? I like the low-level stuff.
Yeah, that's exactly right. Okay. Well,
sorry, please continue.
I was just gonna say, if you have time, take a look.
Try to do that. By the way, cache line on newer AMD 64 incarnations is still a 64 bytes. However, I'm not pretty sure, but I guess I read somewhere that actually your processor transfers data using two cache lines in the same moment. Basically 128 bytes. But still, one line is 64 bytes long.
Okay. Well, maybe we could have there should be a pound defined somewhere that says what the cache line alignment should be instead of hard coding 64 everywhere. That'd probably do the trick. Okay.
And I'll try to send you information that we have about related to that if you're interested.
Sounds good. Okay.
Radislav. Thank you.
Thank you. All right. Okay, so that's cache lines. Looks like Mark put some stuff here already on Blue Store. Ongoing testing for small string tree. Do you want to talk about this, Mark, or I already talked about some of it, I guess?
Yeah, I kind of mentioned it before you were here too. So I guess Nick, you might be interested in at least kind of paying attention to some of this or trying it out, or yeah.
Probably try master. It should be. Have you had a chance to test it actually, Nick, since this stuff has gone in?
No, I'm sorry. I'm just really snowed under at the moment. I'm hoping probably in about the next week things will calm down a bit and I can get back onto testing some of this stuff.
Cool. Okay. Yep. Yeah. No worries. But I think it's in much better shape than it was last time you looked.
Great.
The latest test that Mark ran, basically for queued up to 1, it was the same latency as file store, which is sort of what you'd expect. We're basically limited by the speed of the hard disk seeks. So I just need to make sure that the case for the journal is on NVMe and the rest is on the disk. We need to make sure we're dealing with that case properly. And in the past, we've seen that once you increase the queue depth, then BlueStore does much, much better. But I want to double check that and make sure that it's my memory matches reality. So.
Okay. When you've been doing the testing, have you been fixing your C states and frequency? Because I found I can get about a 4 or 5 times performance improvement by doing that when in those sort of tests.
Fixing C states?
The CPU state, if it's like...
Oh,
right?
I know I'm not doing any of that.
Okay.
But I assume that my processors aren't going to sleep because they're usually pretty busy. So maybe.
So, hey Nick, would you mind?
Yep.
I think maybe you've documented it before, but if you have any documentation or if you remember writing anything, could you send that to me so I remember what all you're doing?
Yeah, I can send that across. Yeah, I mean the good way to check is use something like PowerTop, or there's a tool called i7Z. I mean, even if you're sort of pummeling sort of a few hundred IOs for a node, I was finding that the C states were spending most of the time in like C6, and I think there's something like a 200 or 300 microsecond delay for that CPU to wake up, and because the Linux scheduler is not power aware, the running threads basically hop between all the cores, so just randomly you're just getting massive delays. So I was seeing, like, without that I could probably only hit doing like a QDEP1 maybe about 400 or 500 IOPS, but then when I forced the CPU frequency and C state to C1, that went up to 1600 IOPS for a single thread.
What kind of processor was that?
That is a Xeon E3.
Oh, wow. Okay.
So it is running at 3.6, quad core 3.6. But yeah, I was getting a replica to a three-way. Sorry, right to a three-way replica was taking about 600 microseconds.
Yeah, Nick.
Wow.
Honestly, I forgot about your tests, so I need to go back and check to make sure I've actually set these nodes up properly. But yeah, if you wouldn't mind sending me that, I'd really appreciate it.
Sure.
That's good to know. Okay. Anything else we should talk about? I'll mention that Matt's team. Oh, I have a, yeah, okay. So Matt's team is looking at peering latency finally. So they have a cluster set up and they're going to look at sort of the standard scenarios where an OSD goes down, comes back up, it's been down for a long time, comes back up, and so on, and look at what the slow requests are, where they block on peering, and then so we can figure out exactly what it is during the peering process that's blocking them, and so we can fix it so that we can eliminate those sort of long tails when you have those cases. This is sort of a long-standing thing that people have complained about, and we have like a half dozen ideas of things that we could improve, but we're going to do a bunch of testing to actually figure out what the things are that are actually making the most impact, so we can deal with the low-hanging fruit first. So that's in progress. There are a couple open pull requests for changes to peering to fix a few things, but it's unclear whether those are actually addressing the things that are causing the most slow requests. So we want to do the analysis first. This is basically we talked about this on the list, I guess, a week and a half ago with Peter at OVH about this also, because they're seeing the same thing. So hopefully we'll make some progress there. The big thing though, actually, is that I really want to reschedule this meeting. I probably should have talked about this at the beginning, but I would very much like to move this meeting probably just an hour later, unless anybody else has a different suggestion or request, because the Ann Arbor folks generally can't join because there's a conflicting Red Hat internal call that has managers from like a million different groups and is technically impossible to move. So,
well, that's why they sent me.
That's why Adam's here. But Matt complains about it on a near weekly basis. You would really like to be here. And this is also 8 a.m. Pacific, which I imagine a lot of people don't like that much either. So I guess it'll be noon Eastern, which also is sort of a inconvenient time. It'll be later for China.
I think the problem we had last time was the European folks who are going home from work.
So this is going to be, it's going from like 4 to 5 or something like that.
Yeah, something. I don't remember exactly, but yeah. I think that was what the problem was last time.
Well, we have 20 people here who will actually show up. So can we have some sort of vote, I guess, or something? How many people would be okay with moving?
It's okay for me. Adam here.
Okay, so it's okay 1 hour later for you. Not okay for Peter. It's okay for Bruce. Not okay for Bart. So this is basically people in Western Europe, it seems, who are. What time is it for you, Adam? Is it like 7 o'clock or something, or?
Now it's 5:30 p.m.
Okay. So we have 2 nays, basically. Are there people that would 3 nays? Are there people that would prefer an hour later over now versus now? Or is it just a lot of don't cares? Or, not so good for Igor. What about an hour earlier? Yeah. That would be 7 a.m. Pacific, but pretty much better for the rest of the world. What do you guys think about an hour earlier? Not so much for Ben. But Ben, you're East Coast, aren't you?
Yeah, there's a lot of meetings that happen at that time.
Okay.
What about this time on a different day? Would that be another potentially?
Yeah. Yeah, would a different day other than Wednesday make any difference? I guess the same for you, Adam. I mean, for you,
Of
it's like
course,
11
it's the
a.m.,
same.
right? Yeah. Yeah, this kind of feels to me like we should do an hour earlier because there's a handful of people on the West Coast that is going to be more annoying for because it's 7 to 8 instead of 8 to 9. But I think actually we have more people in Europe that are in the going home time period.
Is 2 hours earlier an option? That would not be for the West Coast, right?
That would be 6 a.m. Pacific.
Pretty brutal.
What do you say?
Yeah, never mind.
I think we lose Greg and Josh.
And it lose. Yeah, I think that one would be a little bit harder. I mean, 7 a.m. sucks if you have kids trying to get them to school, but.
What about different day of the week? Like, I mean, because Wednesday just happens to be the busiest day, I think, for meetings like ever.
Yeah, I'm totally agnostic as far as, no, I'm totally. I could do Thursday or Friday, I guess. Would work. What do you guys, does the day of the week make, so that would be better for you, Ben? Thursday, Friday?
Yes.
Okay. But anybody else?
But I'm not as
Sure.
important as some of the other folks on the call, so.
Yeah. But if nobody cares, then we might as well do any day is fine.
Yeah, maybe Thursdays or Fridays would be a better.
I'd prefer to stay away from Friday because it's the last day of the week and often or it's a vacation or whatever.
Yeah.
But Thursday. So maybe Thursday at 1 hour sooner. I need to make my calendar show UTC and not CET, I guess is what I have right now.
Sage would 1 hour earlier more likely hurt the people on the West Coast than this time? I'm not sure. The only reason I ask is because it seems like 10 is kind of like the spot where no one's real happy, but everyone's tolerably happy, maybe.
Yeah, actually, you know what? I'm not sure if just switching the day might be sufficient for Matt. Actually, do you know, Adam? It's just that program call that's on Wednesdays, right?
He has a lot of meetings. I don't know when they are, but I don't think he's particularly busy on Thursday mornings.
Okay.
Let me ask someone else and see if they have a better idea.
Okay. Well, so I guess the two options are it's either same time Thursday or Thursday 1 hour earlier, I guess. Are those sort of the two that we'd consider. So maybe we can just maybe we can follow up on the list with like a Survey Monkey thing or whatever. Just figure out what works for people. Okay. Well, thanks everyone for your input, feedback. Anything else we want to cover? I had one other idea I wanted to throw out for people who are interested in. Yeah, final decision on meeting move we'll do it over email, so we get some final input. So just pay attention to Ceph. Yeah. The last thing I wanted to mention is the new de-encoder stuff changes the encode and decode functions, and so they use different types, and they use pre-allocated buffers, so there's no like splits across buffer segments they have to worry about, which is nice. But most of the code still uses the old bufferless stuff, and it could get converted, but it hasn't been, and it'll probably be forever before that happens. But the one case where that concerns me is that in the append case, in the encode case, basically every buffer list object in memory has a bunch of fields that are there just for handling efficient appends. They have this buffer pointer for the append buffer, and I think they have, there might be an additional field, actually, I forget. But it would be possible to reduce the memory footprint of buffer list if we move that into a separate type and we had a buffer list appender type and then change all the encodes to take the buffer list appender instead of the buffer list. So if anybody's interested in encoding overhead, that might be something to look at. It would probably be a relatively mechanical change because you could just make sure that all the append method basically exists on the appender, and then you could just do a blanket replace type in all the encode methods. But something to consider if anybody's interested in looking at that.
Speaking of bufferless depends, I was looking through some perf results yesterday and saw that either because we've improved other stuff or because this has regressed a little bit, I'm seeing bufferless depends showing up again. So,
for what work? This is like in the
this is like a 4K random write BlueStore workload.
Could you tell whether it was coming from OSD code or BlueStore code?
Oh, I don't remember. I don't think I could tell easily from that particular one because I was missing some symbols for some reason. But
I think that's the thing to look for. If we can figure out which users are actually abusing the bufferless depends, like we can just optimize those ones. In the BlueStore itself, it's using the de-encode dunk code, which is pre-allocated fixed size, not fixed size, but whatever, pre-sized contiguous buffers. So just overhead should be very, very low, or as low as pretty low. So if it's still a problem there, then that's a bigger problem, I guess.
Yeah, might be for folks that like to play around with perf and are interested in the coding, it might be worth someone taking a look.
Yep.
It might be still related to the small encoding code from the old header file.
Yes. Yep. Do you have an update on that, by the way?
Unfortunately, no. I haven't had time for this.
Okay. No problem. Yeah, it occurred to me like immediately after the call last week that if we use if we more effectively use the appender types or methods or whatever, it's just a pointer basically. Is all that class is just wrapping a pointer. That's your right position. Then you can avoid all those function calls, and that it might not be necessary to have the change in the encoding format.
Yeah, that might be even faster.
Yeah. Yep. So we just need to confirm, actually implement it and see what the result looks like. Cool. All right. That's probably it. Anything else? Okie doke. Thanks, everyone. We'll follow up with an email about the scheduling time. Thanks.
Sounds
Thanks
good.
for joining.
CDM is today, by the way, guys.
Oh,
So
yeah.
if you're interested, that's coming up
half
in
hour. 45
yeah.
minutes.
Bye, y'all.
All right.
All right. See ya.
See you guys.
Thanks. Bye.